Hello friends, welcome back. In this video, we are going to study the various terms involved in coordination chemistry. So let's start with this. So we are having the terms involved in coordination chemistry. So the first term that is involved in coordination chemistry is the coordination compound or coordination complex. So what is this coordination compound or the coordination complex? So when complex compounds are those in which the number of bonds are formed by the central metal atom or the ion with the ligands are greater than that expected from the usual valency of the atom or the ion. So when the number of bonds formed by the central metal atom with the corresponding coordinating groups are more than the usual valency of that particular metal atom, then that compounds they are known as the coordination compounds or they are known as the coordination complex. So let's see the example. Its example is the CONH36Cl3. It is known as hexaamine cobalt plus 3 chloride. So let's see its structure. Its structure, that is a CONH36. Now instead of putting this Cl3, we have put over here the plus 3 charge. So at the center we are having one metal, that is a cobalt, and it is surrounded by the 6 NH3 groups. Now here from this structure what we can see, there are 6 bonds between the central metal and the surrounding groups, right? But the actual charge on the cobalt is the plus 3, because on the complex there is a plus 3 charge. That's why cobalt is having the plus 3 charge. That means the valency of the cobalt is 3, but the bonds formed by the cobalts are 6, and hence these type of compounds are known as the coordination compound or the complex salts. So here we can say that the usual valency of CO3 plus ion is 3, right? But the number of bonds formed are 6. So it is called as a coordination compound or coordination complex. Now in case of these coordination compounds or the complex compounds, the metal ion may form either a cationic species or anionic species, both cationic and the anionic species, and the fourth one is a neutral species. So there are the 4 species which are formed by the complex compounds. So for the cationic species, we are having the example complex cation PTNH34, which is having the plus 2 charge. As it is having a plus charge, therefore it is a cationic species. For anionic species, the example is a complex anion, which is PTCl4 2 minus. It is having the minus charge, therefore it is the anionic species. Then example of both cationic and anionic species is complex cation and the anion, which is PTNH34 2 plus PTCl4 2 minus. Now here it is having both plus and the minus charge, so it is an example of cationic and the anionic species. And the fourth type of the complex compounds is neutral species, which is having example PTNH3 twice Cl2. Now on this complex ion there is a no charge, therefore it is known as the neutral species. Now here we can say that here the constituent ions or the molecules lose their identity when they are forming the complex salts. Then the second term in the coordination compound is a complex ion. So what are the complex ion? Complex ion means it is nothing but a charge which may be either the plus or the minus charge. So a complex ion is a charged species formed when a metal atom or ion is directly attached to the surrounding coordinating groups, which are also known as the ligand, right? So the complex ion is indicated by enclosing the particular formula of the ion in the square bracket. So we have to put all the formula of the ion. Formula means the metal and the surrounding groups in a square bracket, and that indicates the complex ion. So its example is, the first example is CrCN6 3 minus. Now this formula is put in the square bracket, therefore it is called as a complex ion. Second example is the CuNH34 2 plus. Next examples are MnCl4 2 minus and CONO2 3 minus. And also FeCN6 3 minus and CONH36 3 plus. So these are the examples of the complex ions in which we can say that these are the charged species which may be either plus or the minus, and the formula is enclosed in a square bracket. So let's take one more example, that is the COH2O6 2+. So let's see its structure. So this is the structure of COH2O6 2+. This first one, that is the first structure, is the CO, that is the central metal atom, and it is surrounded by the number of coordinating groups which are the water, and it is having the charge +2, and it is enclosed in a square bracket, therefore it is known as a complex ion. And the second one is the same, that is it is the ball and stick model of the COH2O6, in which at the center we are having the metal is the cobalt, and it is surrounded by the 6 water ligands, that is this is the first, second, third, fourth, fifth, and the sixth. So these are the 6 water ligands which are attached to the central cobalt metal. So this is called as a complex ion. Let's move to the next term, that is a coordinate or the dative bond. Now what do you mean by coordinate or the dative bond? It is a particular type of the bond. Bond means the bond is formed between the two atoms, right? Which is formed due to the sharing of the electrons by both the atoms, right? That means each atom gives its electrons, and due to sharing of the electrons we are getting the formation of the bond. But in case of the coordinate or the dative bond, out of the two atoms, one atom is more electronegative as compared to the other atom. So what happens due to this? The atom which is more electronegative, it gives both its electrons to the another atom, and when both the electrons are given by a single atom, the bond which is formed is known as the coordinate bond, or which is also known as the dative bond, right? So let's see the definition. Coordinate or the dative bond is a special type of covalent bond in which the two shared electrons are contributed by only one of the two atoms linked together, right? So out of the two atoms, only one atom is providing the electrons. Now, as only one atom is giving its electron, that means these electrons must be extra electrons. So these extra electrons, they are known as the lone pair, and the atom which is donating this lone pair is known as the donor atom or the donor site. So we can say that the atom contributing the electron pair is known as the donor, and the atom which accept the electron pair is known as an acceptor. The one which is giving the electron is known as the donor, and the other atom which is accepting the electron is known as the acceptor. And further we can say that the electron which is donated is known as the lone pair, right? Now how we are showing this dative bond? This dative bond is shown by a single headed arrow, right? A single headed arrow, and the direction of this arrow is from one atom which is donating the electron to the another atom which is accepting the electron, that is from donor to acceptor. So we can say that the bond is usually shown by a short arrow like this, from donor to acceptor, and the arrowhead is directed from the donor atom to the acceptor atom. So this is regarding the coordinate or the dative bond. So let's see the examples. So this is the first example of the coordinate or the dative bond. Here we can say the complex ion, that is CONH3 3+. Now at the center we are having the central metal, and it is surrounded by the number of NH3 molecules or the coordinating groups. Now each nitrogen is having an extra electron which is known as a lone pair, and this lone pair is shared to the cobalt. That means the bond formed between the cobalt and the nitrogen is due to the donation of electrons from nitrogen to the cobalt. So such type of bonds, they are known as a coordinate bond or the dative bond, right? Another example. This is another example in which there is a coordinate or the dative bond formation between the NB, nitrogen, and the boron. Now here the one atom is more electronegative and the another atom is less electronegative. So nitrogen is more electronegative because it is having a lone pair of electron. So it is sharing its lone pair to the boron. That's why there is a formation of the dative bond, and the arrowhead is from nitrogen to boron. Similarly, one more example. Al2Cl6. Now here there is a formation of the dative bond between the aluminium and the chlorine. Again aluminium and the chlorine. Now we know that chlorine is more electronegative as compared to the aluminium, as chlorine is having an extra electron, and that electron is donated to the aluminum for the formation of the bond. So these type of bonds, they are known as a coordinate bond or the dative bond. So this is regarding the coordinate or the dative bond. Let's move on. We are having the next term used in the coordination chemistry is the central metal atom. So what is the central metal atom? The atom which is present at the center of a neutral compound. Neutral compound means which is having a no charge, no plus charge or the minus charge. They are known as a central metal atom. So we can say the metal atom present in a neutral complex compounds to which two or more neutral molecules are attached is called as the central metal atom. So its example, in case of the NiCO4, this CO, that is a carbonyl, they are the surrounding groups, coordinating groups. And these four coordinating groups, they are attached to the nickel. So here this nickel is the central metal atom. One more example, FeCO5. Again these carbonyls, they are the surrounding groups, coordinating groups, and they are attached to the central Fe metal. So this Fe is called as the central metal atom. Right? So let's see the example. CONH3,4Cl2, right? Again we are having this cobalt which is attached to NH3,4. So this cobalt is attached to these four coordinating groups, and this cobalt is present at the center. Therefore it is called as a central metal atom. So let's see its structure. So this is the structure in which we are having at the center of cobalt, that is the central metal atom, and it is surrounded by the 4 NH3. That is, this is the first NH3, second NH3, third NH3, and the fourth NH3. 4 NH3 and 2 Cl. So this, that is the cobalt, is called as the central metal atom. Then next term is the central metal ion. Again we can say that the metal which is present on a charge species. Charge means which is having the plus charge or the minus charge is known as the central metal ion. So the metal ion present in a complex compound to which two or more neutral molecules are attached is called as central metal ion. So its example, in case of FeCN6 3-. Now it is having a charge. So this Fe is called as the Fe3+, which is central metal ion. Again CONH3,5Cl2+. Again this cobalt is having the charge 2+. So this CO2+ is known as the central metal ion. So its example, let us take an example of FeH2O6 3+. Now this Fe means Fe3+. You can see from this structure, Fe is present at the center and which is having a charge. Therefore, it is called as the central metal ion. Here we can see this Fe3+ is present at the center and it is surrounded by 6 H2O. And they are 1, 2, 3, 4, 5 and 6. So in this way, there are 6 H2O coordinating groups which are present, which are coordinated to the central metal ion Fe3+. Okay, so this is regarding the central metal ion. Then the next term that we have to study is the coordination number, right? So what do you mean by coordination number? The number of ligands, or what we can say, the coordinating groups which are directly attached to the central metal atom or the ion is known as the coordination number, right? So how many ligands, or we can say the coordinating groups, are attached to this central metal atom or the ion determines the coordination number. So this is the structure. You can see at the center we are having this central metal atom or the ion, and it is surrounded by 1, 2, 3 and the 4 surrounding groups. So as there are 4 surrounding groups which are linked to the central metal atom, or we can say the ion, so the coordination number of this central metal atom is the 4, as it is attached to the 4 coordinating groups. So the most common coordination numbers are 4 and the 6. So when the coordination number 4 is there, then the geometry possibles are the tetrahedral and the square planar, whereas for the coordination number 6, the geometry possible is the octahedral. So these are the two most common coordination numbers. Whereas The less common coordination numbers are the remaining other than 4 and 6. That is the 2, 3, 5, 7 and the 8. They are known as the less common coordination numbers. So, let us see a table of the coordination numbers of some common ions. So this is the table in which there is a coordination number of some metal ions and also their complex ions. So first 3 rows shows the coordination number 2. Coordination number 2 means the central metal atom or the ion it is attached to the 2 coordinating groups. So if we take the first example of the metal ion, that is a Cu+. Cu+, it should be attached to 2 coordinating groups. So it is CuNH32+, right? The second is the Ag+. It is again attached to the 2 Cn. Again Ag+, it is attached to 2 NH3, right? So in this way, the coordination number 2 means the metal ion should be attached to the 2 coordinating groups. The next one, the next coordination number is the 4. The next row shows the examples with the coordination number 4. That means that these metal ions, they should be attached to the 4 coordinating groups. Okay, so here in this way we can see there are the 4 coordinating groups which are attached to these metal ions. Again, see more examples for the coordination number 5. For the coordination number 5, we are having the metal Fe with the 0 oxidation state and Mn with the 0 oxidation state. So their examples are FeCO5, that means the 5 coordination number, and again MnCO5 means the 5 coordination number, means the 5 coordinating groups, they are linked to the central metal atom. And the next, there is the coordination number 6. So these are the metal ions in which the ligands, or we can say that there are the 6 coordinating groups which are attached to the central metal atom or the ions. So this is regarding the coordination numbers. So here we can say that there are some metal atom or the ions which may show more than one coordination number in different complexes. That means suppose if you are having this Fe3+, in some complexes this Fe3+ is having the 6 coordination number, but in some complexes it may have the 4 coordination number or it may have the 2 coordination number. This indicates that some metal atom or the ions may have more than one coordination number in different complexes. Okay, so these are the some terms which we have studied in this video. In the next video we will see the remaining terms. Thank you.